Hello guys and welcome back. Today is part 5 of AC motor control methods. Today's part 5 talks about automatic starters for start delta motors. We're going to talk about the markings of a start delta motor starter and the motor. We're going to talk about the purpose and function of a start delta starter. We're gonna talk about the connections and, troubleshooting methods for some motor starter. And we're gonna talk about the actual connection of the start delta motor and the starter itself. A commonly used means of reducing inrush currents without the need of external devices is a start delta motor starter, sometimes called a wide delta starter. Start delta motors are similar in construction to standard squirrel cage motors. However, in start delta motors, both ends of each of the 3 windings are brought out to the terminals. If the starter used has the required number of properly wired contacts, the motor can be started in start and run in delta. The motor must be wound in such a manner that it will run with its stator windings connected in delta. The leads of all the windings must be brought out to the motor terminals for their proper connection in the field. Applications. The primary application of a start delta motor starter are for dry centrifugal chillers of large central air conditioning units, for loads such as fans, blowers, pumps, or centrifuge units, and for situations where reduced starting torque is necessary. Start delta motors also may be used where reduced starting current is required. Since all the stator windings are used and there are no limiting devices such as resistors or auto transformers, start delta motors are widely used on loads having high inertia and a long acceleration period. The speed of a start delta or wide delta squirrel cage induction motor depends on the frequency of the applied voltage and the number of stator poles. Since both these values are the same for the Y or delta connection, the motor will run at approximately the same speed regardless of how the windings are connected. The inrush line current is much less when the windings are connected in Y. However, assume that a motor is to be connected directly to a 480 volt line during the starting period. Also assume that each winding exhibits an impedance of 0.4 ohms during the starting period. If the windings are connected in delta, when the power is first applied to the motor, 480 volts will be connected directly across the phase windings. This will produce a phase current of 1200 amps. Since the light current supply in a delta connection is 1.732 times greater than the phase current, the line current will be 2078.4 amps. Ohm's law will tell us that 1200 times 1.732 equals 2074.4 amps. If the stator windings are connected in a Y configuration during the started period, the inrush line current will be only 1/3 the value of the delta connection. Since the windings are now connected in a Y or star, the voltage applied across each phase winding will be less than the line voltage by a factor of 1.732 or 277 volts. Because 400 divided by 1.732 equals 277. This will produce a phase current of 692.8 amps when power is first connected to the motor in a Y-connected system. The line current and phase current are the same. Therefore, the line current has been reduced from 2078.2 amps to 692.8 amps during the initial starting period. Overload protection. 3 overload relays are connected in the phase winding during both the starting and running period. As you can see in the following image, this means that the overload heaters must be selected on the basis of the winding or phase current, not on the full load line current indicated on the motor nameplate. To determine the proper current for the overload heaters, divide the line current by 1.732. A diagram of the entire connection for the motor windings, overload heaters, and load contacts is shown in the following image. Open transition starting. Probably the most common method for Y delta starting is open transition starting. This method receives its name from the fact that the motor windings are open during the transition period of changing the windings from a Y connection to a delta connection. A control circuit for performing this transition can be seen in the following image. In this circuit, a non-delay timer is used to change the motor windings from a Y connection to a delta connection. When the start button is pressed, coils 1M, TR, and S energize immediately. Coil 1M closes all 1M contacts to supply power to the motor windings. Coil S closes both of the S contacts that connect the motor winding in a Y connection. After some period of time, both TR contacts change position. The normally closed contacts connected in a series with an S coil open and de-energizes the S coil. The S loads contact open and disconnect the motor windings. When the normally open TR contact closes, coil 2M energizes and reconnects the motor windings in a delta configuration. It is the transition period between S contacts opening and 2M contacts closing that this starting method receives its name. The normally closed S and 2M contacts act as interlocks to prevent the possibility of coil S and 2M being energized at the same time. Care should be exercised when connecting the stator windings to the load contacts. If the circuit is not connected properly, it will generally result in the motor reversing directional rotation when the windings are changed from Y to delta. In the following image, you guys can see a schematic diagram of the stator winding connection and a wiring diagram of the motor connection to the load contacts. Notice that the wire numbers have been added to a stator schematic, which corresponds to the components shown in the wiring diagram. Closed transition starting. In the above image, resistors maintain continuity to the motor to avoid the difficulties associated with the open circuit form of transition between start and run. With closed transition starting, the transfer from start to delta connection is made without disconnecting the motor from the line. When the transfer from start to delta is made in open transition starting, the starter momentarily disconnects the motor and then reconnects it in delta. While an open transition is satisfactory in many cases, some installations may require closed transition starting to prevent power lines disturbances. Closed transition starting is achieved by adding a 3-pole contactor and 3 resistors to the starter circuit. The connections are made as shown in the following image of the schematic diagram. The contactor is energized only during the transition from start to delta. It keeps the motor connected to the power source through the resistors during the transition period. There is a reduction in the incremental current surge which results from the transition. The balance of the operating sequence of the closed transition starter is similar to that of the open transition start delta motor starter. A single method of reduced current starting may not achieve the desired results because the motor starting requirements are so involved, the restrictions so stringent, and the need so conflicting. It may be necessary to use a combination of starting methods before satisfactory performance is realized. For special installations, it may be necessary to design a starting system to fit the particular conditions. Thank you guys for watching, and again, please like, share, and subscribe.